It started as a rumor on Reddit, then spread to TikTok astronomy pages, and by the weekend it was everywhere. 3I/Atlas has changed color 3 times. The claim was explosive, suggesting the mysterious interstellar object wasn't just brightening, but morphing, flashing hues from green to red to blue in a span of days. Some users even joked it was signaling. Others went further, calling it the first living comet. But when astronomers finally weighed in, the truth was stranger and subtler than the viral headlines made it sound. 3I/Atlas, the third confirmed interstellar visitor ever detected, is already a once-in-a-lifetime event. Discovered by the Atlas telescope in July 2025, it's been rushing through the inner solar system at blistering speed, shedding gas and dust as it nears the sun. But when photos began circulating in early November, showing the comet glowing first emerald green, then copper red, and finally icy blue, the internet decided something extraordinary was happening. The raw images looked convincing. Amateur astronomers from Chile, Japan, and Spain all shared stacked exposures showing dramatically different colors. News outlets latched on, declaring 3I/Atlas the color-shifting interstellar visitor. Some compared it to the Northern Lights. Others hinted at artificial technology, claiming the object was flashing coded signals as it rotated. The problem? None of those photos were taken under consistent conditions. Astronomers analyzing the data quickly pointed out that each image had been captured with different filters, cameras, and atmospheric conditions. A comet's color in photos is heavily influenced by exposure time and the sensitivity of the detector to certain wavelengths. If one telescope uses a green filter, you'll get a cyan hue. If another photographs the same object in red or near-infrared, the glow looks crimson. Stack them side by side, and it looks like a disco ball. Still, there was something worth investigating. When the Hubble Space Telescope and the European Southern Observatory both imaged 3I/Atlas in mid-November, they noticed something real. The ratio of light it emitted in different wavelengths did shift slightly over time. Not dramatically, but enough to suggest a real physical change, not just a photographic illusion. So what's actually happening? To understand that, you need to know what makes comets glow in the first place. Most of the color comes from gas emissions, specific molecules absorbing sunlight and re-radiating it at characteristic wavelengths. Cyan and green hues usually mean the presence of diatomic carbon, C2, or cyanogen, Cn. When you see reddish or orange tones, that's often sodium or dust scattering sunlight at low angles. A bluish tint can come from ionized carbon monoxide or nitrogen gases being blown by the solar wind. In other words, a comet's color is like a weather map of its chemistry, and chemistry can change. As 3I/Atlas moved closer to the sun, it entered a regime of intense heating. At first, the green glow dominated, caused by carbon compounds sublimating from its surface. Then, as temperatures rose, sodium emissions briefly spiked. These produce an orange-red hue in long exposures. Later, as the object swung past perihelion and began cooling, gas jets on the night side started emitting more ionized carbon monoxide, which glows pale blue in ultraviolet-sensitive images. So yes, in a sense, it did change color, but not the way TikTok thought. It wasn't flickering in real time or flashing like a beacon. It was evolving chemically, layer by layer, as the sun roasted new material out of its nucleus. Each stage corresponded to a different layer of volatile ice being exposed. The green came from the outer crust where carbon chains dominated. The red appeared when sodium compounds deeper inside began venting. The blue came last, as the deeper, colder volatiles finally sublimated. Think of it like cutting into a cosmic onion. Each color marks a new layer being peeled back. The timing also fits perfectly with what telescopes recorded. Around late October, 3I/Atlas was roughly 0.8 astronomical units from the sun, close enough for carbon compounds to vaporize. In early November, when the red phase was reported, its surface temperature peaked, explaining the sodium burst. By late November, as it swung away, Hubble's ultraviolet instruments picked up enhanced CO emission, matching the shift to blue. But there's another twist. The brightness changes that accompanied each color phase weren't entirely smooth. The comet flared dramatically while hidden behind the sun, surprising even the professionals. Some scientists think the heating caused explosive outbursts that temporarily changed the balance of gases, exaggerating the color shifts. Others argue solar wind storms may have ionized parts of the coma unevenly, altering the visible spectrum. Could any of this be artificial? That's the question internet forums keep circling back to. The short answer: no evidence. If it were emitting structured or repeating light patterns, like a signal, spectrographs would pick that up immediately. Instead, all the detected emissions line up perfectly with known chemical signatures. The flashing seen in viral videos comes from atmospheric distortion and inconsistent exposure timing. Nothing indicates intent or pattern. That hasn't stopped the conspiracy theories. One thread claimed the color shifts match the red, green, and blue wavelengths of a typical communication laser. Another insisted NASA was hiding data about periodic radio bursts from the object. In reality, no such signals have been detected. Radio telescopes around the world, including ALMA and Chile and the Deep Space Network, have reported only faint, broadband noise typical of outgassing comets. Yet, the fascination isn't misplaced. This is the first time we've watched an interstellar object visibly evolve over weeks, revealing its chemistry layer by layer. For planetary scientists, that's thrilling. It means we're literally watching alien ice melt. To put it in perspective, 1I/Oumuamua, the first interstellar object discovered in 2017, was frustratingly featureless. No coma, no tail, no color change at all. 2I/Borisov in 2019 was brighter, but chemically familiar, almost like a regular comet. 3I/Atlas, though, is different. It's dynamic, reactive, and complex. It's the first interstellar visitor we can see transforming before our eyes. That transformation tells a story. Its extreme carbon dioxide content, weird nickel-cyanide ratios, and sudden brightening all point to a body formed under very different conditions from our own solar system. When sunlight hit it, it didn't behave like a normal comet. It boiled in strange ways, releasing gases that glowed in unexpected colors. Each hue we saw was a signature from another star's backyard. And that's what makes the viral frenzy both frustrating and poetic. The color changes weren't proof of life, messages, or spacecraft maneuvers. They were chemistry speaking across the stars. They were the fingerprint of an alien nursery, printed in light. Astronomers are still studying the exact ratios of those emissions. Spectra taken by JWST show an unusually strong CN line compared to C2, and an almost complete lack of water vapor. Another reason the colors behave differently. Water is what normally gives comets their soft, milky glow. Without it, 3I/Atlas looks harsher, more metallic, more otherworldly. So yes, you can say it changed color 3 times, but the real explanation is far more elegant than anything viral media imagined. It didn't decide to change, the sun sculpted it. Layer by layer, photon by photon, radiation stripped away its frozen past until we glimpsed what lay beneath. In the end, the color-shifting comet story reveals something deeper about how we see the universe. Our cameras, filters, and human biases often turn raw physics into spectacle. But behind every viral image is something even more miraculous: the raw, unfiltered chemistry of creation itself. For the next few weeks, 3I/Atlas will continue to fade as it leaves the sun's glare, drifting outward toward the cold again. The hues will settle back to dull gray. The online buzz will die, but somewhere in those fading colors lies a message, not from aliens, but from physics. A message that says, matter from other stars behaves by the same rules, even when it surprises us. The claim was half true. The hype was wrong, but the wonder? That was completely real.